This video was part of my project for my statics class at Valdosta State University, teaching by Dr. H. Spring 2024. Today we're gonna solve the problem 4.8 of the statics books, which says a 5 by 8 feet sign of uniform density weighs 270 pounds and is supported by a ball and socket joint at A and two other cables. The question says determine the tension in each cable and the reaction at point A. So we want to find the tension of the cable C to E, D, B, and the reaction at A. Here on the free body diagram, we can see like C has the coordinates of 0, 2, 0, 3, and 2. D has coordinates of 0, 4, and negative 8. And according to their other points, we can just find that their forces is equal to negative 6 feet I plus 3 feet J plus 2 feet K times 1 over our constant of the force, which is equal to 7 feet for the cable EC, which gives us TEC equals to minus negative 6 over 7I plus 3 over 7J and plus 2 over 7K. We did the same with B, and it's just like the answer is going to be the tension of TV times 2, negative 2 over 3I plus 1, 1/3 of J, negative 2 over 3K. So to find this, we just need to know that the body is in equilibrium, so all the forces are going to be equal to 0. And in this case, we have 3 forces for point A because it's a jerk a ball and a socket joint. So it has no rotation, but it has all forces in all the 3 angles. So we are going to say like it is AXI plus AYJ plus ACK plus the tension from our 2 cables minus the weight of the sign, which is 270 pounds. We just plug in what we have right now. So this is gonna be this, our formula. And to solve it according to the point A, we're just gonna replace here. It's gonna be the summation of R times the forces, which is equal to 0. And in this case, we start with the point B, which is equal to 8 feet, the distance, times or TD or TBD, which equals all this. Then we're going to the second point, which is E. So it's going to be plus 6 feet I times or tension of this cable, this one. And the last one is just going to be this middle point, which is the center of gravity of this sign, which is equal just like the half of the sin, so just 4. So it's going to be 4 times the weight, 270, because it's a negative 4, just negative. Then we can separate these two, this equation into 2 equations because I times I equals 0. So we're just going to have to solve for K and J. First, we're going to select K, which is we're just going to solve by one of these. In this case, I just solve by D of BD, which is just this. Then we replace on the second equation to find TEC, which is equal to 315 pounds. Then we just take this value and plug in, and it's gonna solve the second one. Then the problem is asking us from the reaction of the point A, so we're just gonna see what are the forces. So we just go back to the beginning. Here we solve for I, J, and K. We have 3 equations. We just plug in our new values on this equation. here, and we just solve by AX, which equals to 338 pounds, AY 101.2 pounds, and AC 22.5 pounds. Now we're just gonna see which is the tension of both cables. So we just go back to here and we just plug in our new value here and multiply by here. We're just gonna have like the cable DVD has a reaction on the x-axis of nearly 67.53 pounds, on the y-axis at 767 pounds, and on the the c-axis is at negative 67.53 pounds. For the other cable, it's gonna be a negative value on the x value of 270 pounds. On the y, it's gonna be 125 pounds. On the z-axis, and 9 pounds. Thank you.